Again, you've heard talks about this before, but pesticides contaminate our food and drinking water. They also are responsible for either directly killing many beneficial insects and birds or indirectly killing them. So, for example, the monarch butterfly, the reason that the non-GMO project has the monarch butterfly as its icon is that monarchs basically eat one thing. They eat milkweed, which unfortunately for the plant has the word weed in its name. Milkweed is actually a beautiful plant. I have some in my garden. And monarchs feed on it. If farms spray herbicides on their farms, it's killing the milkweed. Now, they're not intending to destroy monarch butterfly populations, but they are. So monarch butterfly populations are running at around 4%. 4% of their historical norms. It's because they have nothing to eat. It's not because we're killing the insects directly. What we're doing is we're killing their food supply. Get rid of the milkweed, you're going to lose monarch butterflies. You know, you may not like getting stung by bees. This probably happened to you 2 or 3 times in your life. That's not a reason to kill all bees. Now, bees, you know, if you only want an economic reason to think about this, about 1/3 of our food requires pollination by bees. No bees, no food. Ironically, there's a kind of insecticide known as a neonicotinoid, and it is made by a company called Bayer in Germany. It's illegal to use it in Germany. In fact, it's illegal to use it in all of Europe, but we use it in the United States. And it's considered to be a primary contributor to bee colony collapse disorder, which is happening all over the place now and is really a significant problem. That's a graph of monarch butterfly populations dropping down now to somewhere around 3 or 4%. Runoff. So once you spray all your farms with these chemicals, or you spray your lawns with all these chemicals, eventually, especially the fertilizers, they will run off your land into local creeks, local rivers, and eventually into bays. So this happens to be the Chesapeake Bay in August. I don't know if you know about this. I'm sure it's happening in New York. It's happening in every major watershed in the country. Fertilizers, which are obviously designed to make plants grow, when it rains, they run off. It runs off into the creeks, runs downstream, where it continues to fertilize, except it's not fertilizing farm crops, now it's fertilizing aquatic plants. So it runs down, and you see all that green slime, which everybody knows. This has become a very recognizable phenomenon. What has happened is the fertilizer is fertilizing algae in the water. That algae lives for about 24 hours. It grows really fast on all this like supercharged fertilizer, and then it dies. And as it dies and decomposes, the decomposition process sucks all the oxygen out of the water. And so what you have are what are known as dead zones. There is no oxygen in the water because of all the algae that is dying because it's been super fertilized. These dead zones are so big now that you can see them from outer space. So there's Lake Erie, the Gulf of Mexico. Those are satellite images of algae, what are known as algae blooms. So this is another reason to stop using fertilizer on your lawns, because that stuff is contributing to those algae blooms. So in the book, I spent a fair bit of time in Hawaii, including on the island of Kauai. Kauai is a place where a lot of these companies have what are known as experimental farms. They rent out this land, and then they grow these GMO seeds, and they spray them and 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 see what kind of things work and what kind of things don't work. When they figure out what kind of seeds work, they then scale them up and sell them to farmers all over the world. Kauai is where it starts. All the big players have experimental farms there. And they're very reluctant to tell anybody what they're doing. They don't tell you what kind of chemicals they're using, or how often, or in what concentrations. And you might not know this, but Kauai, you can visit there as a tourist, but people live there. I mean, it's an island with, a very healthy, regular resident population. When those people went to these big companies and said, would you please tell us what you're spraying because we got schools and villages right down the road. The company said, no, that we won't tell you. So then the people got frustrated and they went to their elected officials and say, yo, elected officials, will you please tell these companies to tell us what they're spraying and what concentrations and how often? And the politicians went over there and the company said, no, we're not going to tell you what's going on. So I showed up over there and I got a local person who knew about this to drive me around and show me where these fields were. And this is a map that she created. The red areas there are where these experimental farms are happening. They happen to be, a lot of them, on old abandoned sugar plantations. So you drive around there and you see these big vats of chemicals. No idea, no labels, no idea what's going on in there. So this starts happening. The companies refuse to tell anybody what's going on, so people get more and more angry. They start to do all kinds of crazy street theater, trying to get these companies to cough up some information. They just want to know what they're using, and the companies are incredibly reluctant to do it. So eventually this became a political issue. Now, the island of Kauai, like all islands in Hawaii, is a county. Like the form of government there is a county government. And the county council there passed a law because they were so pressured by local residents. They passed a law forcing these companies simply to tell them what they were using. The companies didn't like the fact that people had voted this, so they challenged this law in federal court. And a few months ago, the companies succeeded in federal court, and now they once again no longer have to disclose what they're using. Now, Andrew Kimbrough, who was on the panel last night, has spent a lot of, he's a lawyer working on these environmental issues, is very involved in all this, and was describing how convenient it is to have local laws overridden by federal laws. It turns out that these industries are much happier controlling federal policy than they are local policy. They have much more control in Washington than they do in local communities. So to me, the reason I write about this is this seems to me like a fundamental issue of democracy. Like, people don't get to decide what happens in their own neighborhoods, on their own land. This is decided in Washington at the behest of federal regulators and giant global corporations. So what's happening now, as the United States market is now fully planted and we're all eating this food, now these companies are pushing to broaden their markets by going into places like South America and removing forests, as they did here, and planting monoculture crops to raise industrial meat. So when you hear, depressing stories about the deforestation of the Amazon, for example, one of the reasons it's happening is because of this. So it is reasonable to mention that my book has a lot of very strong criticism of industrial food and the way that GMOs are plugged into it, but it's not like anti-GMO as a technology. Now, not everybody agrees with me about this, but I feel like there are reasonable uses of genetic engineering, provided that it is done at a scale and with certain, small-scale objectives in mind. On the Big Island of Hawaii, this has now become a kind of a famous story, and it's a story I should tell you right up front is often manipulated, which I'll describe. In the 1950s, there was something known as the papaya ring spot virus, which came through and basically killed papaya plantations. And in the 80s, it jumped over to the Big Island of Hawaii. Had a very active papaya economy, papaya plantations. So luckily, this is a guy named Dennis Gonzalez. He was a local scientist who worked at Cornell University. And people came to him and kind of desperately said, is there any way you can figure out a way to help us create a genetically modified papaya that will survive this virus? And he got into his laboratory using public money, not corporate money, right? He was a university researcher. And he discovered a way to make a papaya plant grow that was not susceptible to ring spot virus. And now, if you visit, these are photos that I took, the papaya plantation on the Big Island is very healthy and thriving. So, here's an example of a successful use of genetic engineering that helped local farmers create small-scale crops that are, in the scale of things, relatively benign. Now, because of the success of this, the big corporations, which, by the way, had nothing to do with developing this, like to advertise this as evidence that GMOs are fabulous and benign and harmless for all GMOs, which is not true, because a few acres of papaya plants is not the same as 200 million acres of GMO corn and soybeans. That creates a nutritious plant. GMO corn and soybeans creates the industrial food system. So those are not the same thing. So when someone says GMOs can be used to feed the world, you have to ask, like, what are you talking about specifically? And there's more to say about this, and if anybody's interested in the GMO and the papaya thing specifically, there are complexities. Like, for a long time, Japan, which was a big market for these papayas, would not buy GMO papayas. They didn't want GMOs of any kind. So all these GMO papayas couldn't get into the Japanese market. So the Japanese were no longer buying American papayas, which actually put negative pressure on the papaya economy and all. I mean, it's a complicated story. But I just want to use this as an example of how genetic engineering can be used in a way that can be beneficial at a small scale for certain kinds of people and places. But on the mainland, what we're talking about, well, let's finish this story. So in St. Louis, there's a place known as the Danforth Center. It's a really famous, very well-funded research center that is doing things like creating nutritionally enhanced, genetically modified crops. So in Africa, a lot of people eat a root crop known as cassava. It's got a lot of calories. It's very, it fills your belly, but it doesn't have a whole lot of vitamins in it. And in Africa, like in other developing parts of the world, there are a lot of children that are born with nutritional deficiencies. In this case, we're talking about beta-carotene. If you don't get enough beta-carotene in your body, you don't create vitamin A, and it means you can go blind as a child. So if you eat traditional cassava on the left, which is white, you have no beta-carotene. In other words, you can get calories, but you can't get vitamin A. If a scientist can create a cassava plant that has beta-carotene built into its genetics, a kid who eats the orange cassava will get both the calories and the vitamin A. Seems like a great idea. You've probably heard about this done in Asia with something known as golden rice, where they take beta-carotene and stick it into the rice crops so that people who normally only eat rice are now getting beta-carotene in their rice. It doesn't happen naturally. You can engineer it to happen. So those seems like, reasonably good ideas, right? It's a way to reduce, infant blindness, infant mortality. So when you hear stories like that, you can say, sounds good. When you hear someone say, sounds good, therefore all GMOs are good and fine, you should not go down that rabbit hole, because they're not the same thing. So when we're talking about all this monoculture, in addition to the GMO question, there's this question of the monoculture and the annual crop. So and there's a chapter in this book about a guy in Kansas known as Wes Jackson. This guy is an agricultural celebrity. He's a genius. He runs something known as the Land Institute. And what he thinks is that human beings made a deal with the devil 10,000 years ago when we decided that we were going to throw in all for annual crops. And you can see why it happened. So you're a farmer 10,000 years ago in Mexico, let's say, and you have maize, you have corn growing. And one year you see that plant A grew high and plant B grew short. So you're like, you know what, I'll save the seeds from A and I'll plant them again the next year. And lo and behold, some are even bigger, or some produce even tastier corn, or big fat kernels, or whatever. And you start year by year by year, over hundreds of years, you start to hybridize and select the kinds of crops that you want. Sounds good. Every single year, a new crop is planted. The problem is that got scaled up so that now we have to rip up our soil and plant new seeds every single year. And that is when you've got 7 billion pushing 9 or 10 billion people, this becomes a major drag on soil health and water and all that. So what Wes Jackson is trying to figure out how to do is, how can you grow crops that produce food that are not annual plants, they're perennial plants. So you don't have to rip them up every year. You plant them and you can harvest them year after year after year. So if you look at this, here's a plant that he's developing that's known as Kernza, it's perennial, and it has a root system that grows for years and years and years. Now look at the difference between, on the left in those images is annual wheat, and on the right is perennial Kernza. Now, if you had thousands or millions of acres of Kernza that did not require that you rip it up every year. You would not destroy the soil. Also, those deep roots allow the plant to suck up moisture from the soil, so you wouldn't have to irrigate as much. You wouldn't lose as much drinking water. And if you can take the extra step of making this not only perennial, but also what's called polyculture, like plant these plants among other plants, they could help fend off insects and viruses and all kinds of other things. In other words, he's in Kansas, and he is working with what is in Kansas a prairie ecosystem. Like he would like to have land look diverse and integrated, not monoculture like a parking lot. So that's a lot of science and a lot of policy, but I teach a lot of humanities classes, and what I'm trying to figure out is why is it that human beings have become so completely disconnected from their food, no matter what kind of food we're talking about. Like nobody anymore has any idea where their milk came from, where their potatoes came from, nobody. Like somebody might say, well, I think my lettuce may have come from California. But now we can eat anything we want in any season we want, in any place that we want, and nobody even knows a farmer anymore. So underneath all this stuff is the fact that we are utterly alienated from one of the most fundamental things, which is what we're eating. So what I do is I teach philosophy in my classes. I teach Aldo Leopold, some of you know him, one of the great American ecologists, who says a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community. It's wrong when it tends otherwise. He introduced this concept of what's known as a land ethic, like you should have an ethical relationship with the land. If you treat your land poorly, it's unethical behavior. In other words, if you eat crappy industrial food, you are actually acting unethically. Maybe not towards another person, but certainly towards the land. We read indigenous literature to try to understand alternative ways of being on this planet, the way we behave, which is to say with European philosophy, especially Cartesian, like really reductionist ideas that the world is just a bunch of tools that we can use to create and engineer things for our own benefit, is actually only one way to interact with the world. There are indigenous cultures all over the world that have different, way more interesting and organic ways of being. I teach things like Buddhism, which is why is it, Buddhism is one of the great, systems of psychological insight. Like, why is it that we're all so addicted to behaving the way we behave? Whether we're on our phones all the time or whether we're eating junk food all the time. Why is that? Like, what is that we're hoping? Why do we have lawns? What is it that your lawn seems to represent about you that you're so obsessed with? Like, what if you decoupled your own identity with your lawn? It's just a piece of ground, after all. But it takes, a little bit of insight to understand this. I teach Taoism, an ancient Chinese philosophy, which, for my money, is about the greatest environmental philosophy ever created, which says things like, the very best way for you to behave is to get yourself in line with the way that nature actually already is. Like, nature itself is a perfect system. So stop trying to fix it. It doesn't need to be fixed. It doesn't need to be engineered. What needs to be engineered is you. You need to get yourself in line with it. So, in other words, China has a lot more to offer the world than just barcodes. So what else do? I encourage people to eat local, preferably organic, but definitely local. Give your money to local farmers. One second. I also take my students out and teach them how to grow food. Because if an undergraduate in college thinks that potatoes grows on trees, we got a problem. You teach a student that a potato grows in the dirt, and they're like, oh, really? God, I never really thought about that. Maybe I should take care of the dirt. So these are not ag students. These are humanities students out there learning how to grow food. That's my daughter. I also take them out on canoe trips all the time to get them into their local watershed, because nobody knows where water is anymore, right? Nobody knows where water is. Here we live on Long Island. There's water everywhere in theory, but all we see is pavement. How is that possible? There's water under our feet, probably right here. And if you have no connection to water, you have no idea about water pollution. You have no connection with the impact of your life on larger systems. The Susquehanna River is the main trunk line of the Chesapeake Bay. It provides 50% of the fresh water in the Chesapeake. It's also massively, it actually starts in the Catskill Mountains in New York, by the way. The Susquehanna starts in the Catskills, goes all the way through New York, all the way through Pennsylvania, down into the Chesapeake Bay. Is contaminated at every step of the way by agricultural runoff, which you can test for down all the way where I live in Maryland. So we go out and paddle and learn about stuff. And all that is described in this book, Food Fight. It's a complicated story with a lot of history, a lot of stuff going on, and raises a lot of things that I think are worth thinking about. So if anybody wants one, there's some over there. I'd be happy to sign them. And that's all I have to say. If anybody has any questions, I'd be happy to take them. Thank you.